Now we will talk about the situation where the body is on a rough surface. Rough surface means that there is friction and the body is being pulled, body is sliding down. Body slides down. So what is the, there is friction, so what will the acceleration be? Weight is still going to act downward. There is going to be mg cos theta and there is going to be the normal reaction force. This is mg sine of theta. This is also mg sine of theta. Now if the body is sliding down and you push it with the forward force F, there will be some friction F, so in this case the resultant force, or maybe we will ignore the F, we will assume that there is no external force acting, the only force is the mg sine of theta. So the resultant force in this case, meaning the resultant force is still going to be ma, but the resultant force is going to be the forward force minus the backward force. Forward force is mg sine of theta, backward force is F divided by mg sine of theta minus F equals to ma. Divide both sides by m, you get g sine of theta minus F over m is equals to a. Acceleration. This basically tells us if the friction is zero, then if there is frictionless surface, then acceleration is going to be g sine of theta, as we derived over here. If this frictionless surface, if there is friction, there is going to be some resultant force, so g sine theta minus F over m is going to be your resultant force. Now we will look at our last scenario. When the body is being pulled up by a rope. This is angle theta, this is 90. Now we will see that this is a rough surface. There is a pulley. There is a mass hanger over here. Imagine like this is a mass hanger and this is a pulley. So what will happen is that the pulley will apply a tension force or a forward force which will pull, let's say this is slide up. So the pulley will apply a tension force through which the block will move up. Now since it is moving in this direction, a friction force will be generated because the surface is rough. The friction force will be generated in the opposite direction. As usual, we have our component mg. This is mg. This is mg cos of theta. This is the normal reaction force. This is mg sine of theta. Now mg sine of theta will also be acting in this direction. So now our resultant force, which is equals to ma, is basically equal to the forward force minus the frictional force. The sum of forces in the y direction is 0, meaning the normal reaction force and mg cos theta are equal. We will also see two scenarios where friction and mg sine theta and tension, the sum of them is equal to 0, but also when they're not. So forward force is going to be tension T minus frictional force is not frictional force, it's not forward force minus frictional force. The resultant force is forward force minus backward force. Backward force is F plus mg sine of theta equals to ma. In this case, we will imagine that the friction is we will imagine that the body is not in equilibrium, it is moving. It's moving, meaning it is accelerating up. T minus F minus mg sine of theta equals to ma. Divide both sides by m. T minus mg sine of theta minus F divided by m equals to a. T over m minus mg sine theta minus F over m equals to your acceleration in this case. But now we will imagine another scenario. We will imagine a scenario where the sum of the forces in the x and y plane is 0, meaning that the body is in equilibrium. If this is the body and this is a rough surface, body is this is the weight mg, this is going to be mg sine theta. Now this is going to be the forward force, that is going to be the tension T, and this is going to be friction, and this is going to be the normal reaction force. Now let's imagine that while applying tension to move this block up, the block is not moving, it is static. In this case, we imagine that while the pulley is being applied, the tension is being applied, the block is moving upward because the friction was not equal to the tension. Friction plus mg sine theta was not equal to the tension, so it was accelerating upward. In this case, we imagined that there is no friction. In this case, we imagine that tension sum of tension and friction and mg sine theta is 0. The sum of forces in this direction, the mg cos theta and normal reaction force, they are already equal, but the tension and friction plus mg sine theta, they are also equal, meaning that acceleration is 0. So the resultant force is equal to ma. It's the forward force, which is tension, minus frictional force. In this case, acceleration is 0, so the resultant net force is also 0. minus forward force tension T minus backward force F plus mg sine theta is equal to 0. Imagine that resultant force is 0 because friction and mg sine theta and tension are equal. It is not moving the block. T minus F minus mg sine theta is equal to 0. T equals to tension or the forward force equals to F plus mg sine of theta.